Big data enabling technologies. Preface. Content of this lecture. In this lecture, we will discuss a brief introduction to big data enabling technologies. Here, different icons are shown, which are different components which we are going to discuss today. Introduction. Big data is used for a collection of data sets so large and complex that it is difficult to process using traditional tools. A recent survey says that 80% of the data created in the world are unstructured. Hence, traditional tools will not be able to handle such a big data notion. One challenge is how can we store and process this big data. In this lecture, we will discuss the technologies and the enabling framework to process the big data. Apache Hadoop is the tool which is going to be used for the big data computation. Apache Hadoop is an open source software framework for a big data, and it has two basic parts. The first one is called HDFS, Hadoop Distributed File System. The other is called a programming model, which is called a MapReduce. Now we will be looking up the Hadoop ecosystem. For big data computation. So this is the Hadoop ecosystem for big data computation, which is summarized as follows. So as I told you that Hadoop has two main components. That was the old version of Hadoop, which is called a Hadoop version 1.0. Now there was some disadvantage of Hadoop version 1.0. So newer version, which is called a Hadoop 2.0, came into an effect, and this particular picture is about Hadoop 2.0 version, which includes, besides HDFS and MapReduce, another notion of Yarn is being added. So Yarn is a resource manager for Hadoop. This is yet another resource negotiator. This is also called a resource manager for Hadoop, which runs over HDFS. Now HDFS is a distributed file system which is run over the cluster. So below this HDFS will have the cluster infrastructure, and over that Hadoop distributed file system runs, which manages all the nodes and their corresponding memory using HDFS. And the resources which are required by the application is being allocated using the resource manager, which is called a Yarn. And the programming framework for this big data computation is a MapReduce. So in Hadoop 2.0, there are three different main components: MapReduce, Yarn, and HDFS, which runs over the cluster. Now with this introduction of a Yarn, so there are some applications such as Giraffe, Storm, Spark, Flink. They are not going to use MapReduce directly, they run over Yarn and HDFS. Similarly, the applications which will simplify the use of MapReduce further on, called Hive and Pig, they run over MapReduce. Earlier in MapReduce, in Hadoop version 1.0, all the applications were running over MapReduce. Now there is a choice, that means MapReduce or a non-MapReduce applications can run with the help of Yarn HDFS. So now with Hadoop 2.0 it is possible now to have more flexible. So there are various projects which we are going to discuss with the notion, with the introduction of Yarn in Hadoop 2.0. A lot of new projects are there, more than 100 projects are available in Hadoop ecosystem, and they are all open source, that is free. These projects we will discuss some of them which is useful for big data computation. Let us start one by one, that is from HDFS. So HDFS stands for Hadoop Distributed File System. So this particular file system runs over the cluster. So it basically is based on a scale out of hardware resources, that is the nodes can be added, any number of nodes can be added, and this particular style is called scaling out. So it is not always necessary that a very powerful systems are required. So the resources which are required here in the form of cluster, they are called commodity hardware. So these commodity hardwares are prone to failure. So this HDFS provides lot of provisioning for fault tolerance, that we will discuss when we go in more detail of HDFS. So HDFS is a file system over the cluster, and this is called a Hadoop cluster. Over HDFS, the resources are being provided using resource manager for the different application, and this is called a Yarn. Yarn runs over HDFS. So the full form of Yarn is yet another resource manager. It is a flexible scheduling and resource management over HDFS. Now on over Yarn there is a programming model for big data computations, and this will simplify the parallel programming notion using two functions which is called a map and reduce. So Google earlier uses MapReduce for indexing, and they are so powerful that almost all big data applications can be programmed using this paradigm MapReduce, that we will see in this part of the course in more details. Now over MapReduce there are two tools which are available. One is called Pig and Hive. So Hive is created at Facebook. They are all SQL like queries which runs over MapReduce. So complex programming of MapReduce can be avoided using Hive. So Hive will simplify the programming over MapReduce for big data computation. So Hive provides SQL like queries, so it simplifies the entire programming notion, and it was developed or it was created at the Facebook. Now Facebook also uses another tool which is called the Pig, which is the scripting based or a data flow based script programming runs over the MapReduce. So both of these Pig and Hive will augment the MapReduce. So the complex programming of MapReduce can be simplified by using these tools Pig and Hive. Now as you know that with a non-MapReduce application such as Giraffe. Giraffe is a graph processing tool which is being used by the Facebook to analyze the social networks graph, that was made simplified when it was made out of MapReduce. So it uses Yarn and HDFS, and this is a non-MapReduce application for computation or computing large graphs of the social network. So Giraffe is the tool which is now runs over Yarn HDFS, and this is used for the big graphs computations that we will see later on in this part of the course. The next tool which is there is called Storm, Spark and Flink. They are going to deal with the real time in memory processing of the data over Yarn and HDFS. So the fast data or a streaming data applications either can be done using Storm, Spark and Flink, and they basically are in memory computation which are faster than the regular computation. So, stream processing or a real time streaming applications are done using Storm, Spark and Flink over Yarn and SDFS. Now then we are going to see the storage part, the big data, how it can be stored. Now most of these big data is stored in the form of a key value pairs, and they are also known as NoSQL data store. So this NoSQL data store can be supported by the database like Cassandra, MongoDB and HBase. So these particular HBase is over SDFS, and Cassandra and MongoDB, they are also using this kind of for storing the big data applications. So HBase was initially used by the Facebook for its messaging platform. Later on, Facebook also developed Cassandra for the key value store purposes. Now as far as these different components of Hadoop ecosystem, and they are also called as open source projects, which is used for the big data computation. Now another part is called the Zookeeper. Why? Because the names are of some animals. So the Zookeeper is a coordination service which is useful for all these different projects. So Zookeeper is created by the Yahoo to perform the centralized management for synchronization configuration to ensure the high availability that we will see. So these are different projects of this open source framework for big data computation, and this is called a Hadoop ecosystem, and we will be discussing and using in this part of the course in a great detail of it. So now let us see about the MapReduce, which is a programming model for big data component. So it is able to process the large size data sets using two functions which are called map and reduce, which user can specify, and this runs over SDFS in version 1.0, and in version 2.0 using Yarn it can negotiate for the resources from SDFS and runs its application. So this Hadoop ecosystem we can again see in this picture in a great detail. So SDFS will provide and distributed storage, Yarn will provide a resource manager for Hadoop, and for distributed processing, that is the programming for the big data is done through the MapReduce, and Pig and Hive is basically these tools which will simplify the programming of the MapReduce. And there are various other projects which we have seen which basically uses SDFS, Yarn or MapReduce. So this particular entire Hadoop ecosystem is shown in this simplified picture, that SDFS provides storage for big data. The resources like CPU, memory and other resources are being allocated using or managed by the Yarn for different applications like MapReduce. Similarly, there are different other projects such as in-memory computation, that is called Apache Spark, and machine learning over this Spark called Spark MLlib, and this particular project which is called streaming applications over Yarn and SDFS, that is called Kafka and Storm, and the Zookeeper is a centralized service. So this particular entire different projects will form the Hadoop ecosystem, and more than 100 such projects are available free, that is in open source projects, which is used for the big data computation that we will see in more detail. So this particular Yarn resource manager, which is yet another resource negotiator, which is a resource manager for the Hadoop ecosystem, for a Hadoop system, is responsible for allocating the resources to the various applications running in Hadoop cluster and scheduling the task to be executed on different cluster nodes. And this is an open source Hadoop distributed processing framework. It has two parts. One is called resource manager, and this is resource manager. It has scheduler within it. So this particular here the applications can interact with this resource manager and can demand for different resources through YARN. This particular resource manager in turn knows or allocate the resources which are managed at the node level by the node manager, and the resources are nothing but the container in the form of a container. So whenever resources is required by the application, it has to go through the resource manager. A resource manager knows and allocates the resources to the application with the help of node manager, and the node manager allocates the resources in the form of container. So container is the basic resources which are allocated to different applications which are managed internally by every node. So every node is having a node manager, and these particular resources are allocated and reclaimed with the help of centralized resource manager in YARN. And Hive is a distributed data management for Hadoop, and it supports SQL like query option that is called Hive SQL to access the big data, and it is primarily used for data mining purpose. Now we will see the Apache Spark. Apache Spark project runs over HDFS, and this is a big data analytics framework which is in memory computation, so that the lightning fast cluster computation is being performed. So several applications like stream processing, machine learning, and large scale graph processing are already implemented over this Spark core, and we will see that these different projects which are more than 100 plus, to manage them there is a centralized service which is called the Zookeeper. So Zookeeper is a highly reliable distributed coordination service, and which can be used for locking, configuration management, leader election, and so on. So Zookeeper is a replicated service, and it has the attributes, key attributes such as small size, performance sensitive, critical, and it is a part of Apache Zookeeper open source project. And in simple words, it is a central store for the key value pair using distributed system which can coordinate, since it needs to be able to handle the load. So the Zookeeper runs itself on many machines. So that is the internal working of the Zookeeper, but the primarily Zookeeper is used to make the coordination and configuration service of all the projects which are running, which are executing the big data computation using different projects. So that is why the name Zookeeper is being made. Now NoSQL, we see that the traditional SQL can be effectively used to handle the large amount of structured data, but here in the big data most of the information is unstructured form of data. So basically NoSQL that is required to handle that information, because traditional SQL requires the data to be in the structured data format. So NoSQL database is store unstructured data also, where it is not enforced to follow a particular fixed schema structure, and the schema keeps on changing dynamically. So each row can have its own set of column values. NoSQL gives a better performance in storing the massive amount of data compared to the SQL structure. So here you can see that NoSQL database is primarily a key value store. It is also called a column family, and it is different than the relational database management system which is in the form of tables, and this is column families. So, column wise the data is stored in the form of a key value pairs. So, we will see more detail about NoSQL databases, how they are able to store the big data in further slides. Now, another database which supports this particular data model, that is NoSQL data model, is called Cassandra. So, Apache Cassandra is highly scalable, distributed, high performance NoSQL database. So, Cassandra is designed to handle the huge amount of information, and the Cassandra handles this huge data with its distributed architecture that we will discuss in this part of the course. These particular nodes shown over here, that means the nodes are represented in the form of a in the ring. So, all the nodes are, you see that they are placed around the circle, that is called a ring, and this particular ring is the architecture, how these particular nodes, or basically the data center nodes, are organized virtually in the Cassandra architecture. We will see these things in more detail. So, HBase is an open source distributed databases which is developed by Apache Software Foundation. Initially it was the Google Bigtable, and afterwards it was renamed as HBase and is primarily written with high level programming language. HBase can store massive amount of data from terabytes to petabytes. So, this is an HBase which runs over HDFS, and now another project is called Spark Streaming. So, Spark Streaming is used for real time stream processing applications, and this also is called a fast data computations. So, stream processing, Spark Streaming is an extension of the Spark core that enables a scalable throughput, high fault tolerance stream processing of live data streams. Streaming data input from HDFS, Kafka, Flume, TCP, etc. Is taken up in this particular system for computation, and Spark MLlib functions and GraphX are fully compatible to the streaming data for computation. This particular diagram explains the entire computation of the stream processing. So, at the core you can see there is a Spark streaming, and the data which is in the form of a stream enters into the Spark streaming system using the data will be captured either using Kafka, Flume, HDFS, Kinesis and Twitter, and Spark streaming will do the computation on the streams which enters into the Spark core, and after the computation the data will be output will be stored in HDFS or in databases, or basically the visual analysis can be shown on the dashboard. So, for example, if whenever a stream, for example here the Twitter stream or Kinesis or HDFS or a Flume Kafka is read and input in the form of a stream through the Spark streaming, it will be divided into the form of micro batches. This is micro RDDs that we will explain later on, and these micro batches will be processed into the Spark engine, and then these processed values are being generated output either in the form of either will be stored in HDFS databases or dashboard that we will see in more detail later on. So, the data capturing method for streaming is one of such method is called Apache Kafka, is an open source stream processing software framework, and this we will discuss later on. So, through Kafka data streams can be submitted to the Apache Spark for doing the computations. So, this will form a pipeline. So, we will see how this stream processing data pipeline we can form using these different projects which are open source framework available, Apache open source framework. The next project is called Spark MLlib. Spark MLlib is a distributed machine learning framework on top of Spark Core. So, MLlib is the Spark's scalable machine learning library, which consists of common machine learning algorithm and utilities such as the classification algorithm, regression algorithm, clustering, collaborative filtering and dimensionality reduction. All the algorithms which are there in machine learning, they are implemented in this particular framework, and that is why they are called scalable machine learning, and they are available in the form of a libraries that we will see. So, the algorithms which are available are shown over here, and we will see in more detail how we are going to use them in this big data ecosystem. So, Spark GraphX is another Hadoop open source Apache project, and this is the component which is built over the core Spark for computation of a large scale graphs, that is parallel computation of a graph is done using GraphX. So, GraphX extends the Spark RDDs by introducing the new graph abstraction, and the GraphX reuses the Spark RDD concepts that we will see later on and simplifies then on top of it using the different graph analytics, which basically are the graph algorithms which will be applied on this framework. So, GraphX, if we see in more detail, and this is over Spark Core, and the algorithms which are available for doing the graph analytics are the PageRank algorithm, connected component algorithm, and the K-core and the triangle count. All these algorithms are already implemented and made available as a form in the GraphX. So, GraphX is a thin layer on top of the Spark general purpose data flow, and that we will see in more detail, and this is being heavily used for various analytics, that is the graph analytics. In conclusion, we have briefly overviewed the big data enabling technologies. In short, we have discussed about the Hadoop ecosystem, which comprises of the HDFS, file system, Yarn, MapReduce, and then over MapReduce we have seen Hive and Pig, and then various NoSQL databases we have seen the Cassandra, HBase, and then we have seen using this HDFS. Then we have seen in this framework Apache Spark, and over Spark we have also seen the framework for stream computation, that is Spark streaming, and graph computation, that is called a GraphX, and for machine learning we have seen MLlib. Also we have seen about Kafka for getting the streams into the Spark streaming system for computations. So, that is all, and in the next videos we will be going in more details of these different Apache Spark project for big data computation, and we will see how we will be using them for different applications, these projects. Thank you.